Greetings to the audience. I represent Joint Institute for Nuclear Research, and the topic of my presentation is modern physical methods in environmental research for the benefit of mankind. The words at present physics has two very important tasks: care for people's health and care for the environment. All over the world, physics is being reoriented to meet these objectives. These words belong to the scientists from Moscow State University, and with time they are becoming more and more important and reflect the trends of development of research. Why it's important to pay attention to the environmental research? Look, this is the world total population, and as you may found that in 2023 the population of the world reached 8 billion people. So the growth of population is tremendous. Here you see the trends, different models which are shown in that slide. And that slide shows the density of population. At one glance you may see the population which is most dominant in India, in China. In China it's more than 1,000 people per square kilometer. Also, it's important to note the great acceleration in many trends of environmental system and social economic trends. For example, the growth of carbon dioxide starting from the middle of the last century. For many positions we see the growth sometimes exponential, sometimes even tangential. So for social life is the same story, and so acceleration is going on, and we're approaching some critical point which could be dramatic for the development of our world. Why air pollution is so important? Usually I like the words: without food a person can live 1 month, without water 1 week, and without air 5 minutes. So air pollution is a real global problem. Again, you see the dark colors which covered India, China, and some other areas of the world. That slide shows you the death from urban pollution, and again most contaminated areas are the same: India, China, and some Polynesian islands. That slide is very important. Look, this is estimates of percent of COVID mortality attributed to air pollution, and again you see the China dark spots. It gives information that COVID was spread through aerosol particles. Contamination is connected with COVID mortality. At one glance, you can see the situation with water balance in the world. You see droughts in Africa and in Australia and some other parts. Environmental monitoring is a tool to assess environmental conditions and trends, support policy development and its implementation, and develop information for reporting to national policymakers, international forums, and the public. So environmental monitoring is the topic of our research. I shall speak about nuclear analytical techniques which are used in Joint Institute for Nuclear Research. Our instrument is basic instrument, neutron activation analysis. It is an isotope-specific and analytical technique for the qualitative and quantitative determination of elemental content. This definition is taken from Encyclopedia Activation Analysis, and it sounds the basic definition for the method we use in general. Why neutron activation analysis? When we use neutron, we suppose that we use neutron source. In our case, it's reactor, radioanalytical complex Regatta, romantic name Russian-European gate either to Asia or Africa, at IBR-2 pulsed fast reactor. That installation is located on the ground floor of the reactor and is connected with the position of radiation. That quite complicated figure shows you position of irradiation channel 1 and channel 2. We optimize conditions for irradiation when we use either full neutron spectra or part of it. Two containers which you see here, one is metal for long time irradiation, and polyethylene plastic one is used for short irradiation. In addition to neutron activation analysis, we can use atomic absorption spectrometer located in our chemical laboratory. We also can determine mercury using mercury analyzer. And not a long time ago, we purchased inductively coupled plasma atomic emission spectrometry of the kind is given here. You see how many elements we can determine using this facility, in addition to neutron activation analysis. We also measure gamma spectrometry, induced and natural radioactivity, and we use low background gamma spectrometry. You see here the spectrometer dewars for liquid nitrogen, and we use it for measuring cesium-137 and other radionuclides of interest. All in all, we can determine using these three methods, activation analysis, atomic absorption spectrometry, and ICP-OS, we can determine those elements which are marked in green, and plus those in yellow by atomic absorption or ICP instruments. Those elements which are marked in red, aluminum, arsenic, and the other, we report to the European Atlas, which we participate in the program United Nations Economic Commission for trace element determination and radionuclides in Europe, nowadays in Asia, and we expect to extend that program for Pacific region based on MOS analysis. It's a biomonitoring program, international cooperative program for the monitoring and evaluation of effects of air pollutants on vegetation, ICP vegetation, established under the Convention of Long-Range Transboundary Air Pollution by Economic Commission for Europe. Why economic? Because based on the results, it is decided who should pay contribution fee to the place where it's contaminated by other side. So we use mosses. Why moss? Mosses are very special plants which have no roots. They were created so. So that is the picture which shows annual segments with the very special Hylocomium splendens, moss growing in Scandinavia, in the northern hemisphere of the world. And this moss has no roots. It's just taken from the litter. So if we take few upper segments, we can understand what particles were trapped by moss and what so-called atmospheric deposition or wet and dry depositions. This is another picture of different type of mosses. So it was decided that only few mosses growing in the northern hemisphere could be used for the analysis. This is picture showing a teacher from a school of physics who is collecting mosses. It's moss carpet in the Leningradsky region. So mosses are growing practically everywhere in the northern hemisphere. This is the way how moss is prepared as a pellet, which will be sent to the reactor to be irradiated and to apply neutron activation for irradiation of elements contained in the subject of investigation. That picture is taken from the United States website. It shows how many countries signed the Convention on Long-Range Transboundary Air Pollution, and it relates to 2007, but it didn't change greatly. So many countries signed that convention, but not all of them contribute to the convention. So in 2000, the program started in the last century, but it continues to develop, and according to the decision of the 2014, coordination of that program switched to Joint Institute for Nuclear Research from United Kingdom. Why so? Because Joint Institute is an international organization where many Eastern European countries, Western countries were studied well, but United Nations was interested in the air pollution situation in Eastern European countries and in Russia in particular. So in 2014, coordination moved to Joint Institute for Neutron Activation, for Joint Institute for Nuclear Research, and so about 10 years coordination was in the hands of Joint Institute for Nuclear Research. This is a brief history to give you understanding how important that program was starting from the mid, say, of the last century. And as you may note, in the 2015 European MOS survey was coordinated by Joint Institute for Nuclear Research, and even now in the COVID period, that's why it's extended for 3 years, 2020, 21, 22, 6 European survey. So MOSes were collected all over Europe and analyzed by different analytical technique, and in our case they were analyzed by neutron activation analysis at reactor in Dubna. That picture shows the interest of the countries to participate in this program. So you see two scales, number of participants and number of the countries. Red arrows showed the time when the meetings were carried out in Joint Institute for Nuclear Research. That was organized in 2016, and you see how many people from different countries, participants of that program, gathered in the Joint Institute for Nuclear Research. Among them, those newcomers, Armenia, Azerbaijan, Georgia, Moldova, and Kazakhstan, which previously were not participating in the program. But due to Joint Institute, it was easy to invite these countries to provide them with small grants for MOS collection, which is quite consumable which is costly problem. And so, as you may see, that is the just International Intergovernmental Organization Joint Institute, and practically we collaborated with all the countries mentioned in the right column, among them Armenia, Azerbaijan, Belarus, Cuba, and many other countries, including Uzbekistan and Vietnam. These are Asian countries, and if you remember, the program was initially launched for European countries. It's a European program, and we decided to extend that program for Asian countries. Why so? Because contamination in Asian countries is tremendous. You saw the picture, India, China, contaminated extremely. So in November 2022, me and my colleague Alexander Uzhinsky were invited to attend the second online research symposium on air pollution, and you see where trends in Asia-Pacific region, air pollution trends in Asia-Pacific region. So the new initiative was well accepted by the international community, and nowadays we may speak that many Eastern and Asian and Pacific region countries are interested in carrying out air pollution research. What are air pollution global effects, health effects? What air pollution affect? Health effects, increasing greenhouse effect, climate change, global warming or ice age, it depends on the understanding. Acid rain, of course, that was the first known in Europe. Action to reduce air pollution. Why it's so important to assess the environmental pollution and social impact? If we know the reason, we can struggle with it. And continuously upgrade policies, standards and guidelines. That picture gives you an idea what are the main pollution sources. Here, industry, agriculture, migration of circulation of air, contaminants in air. And it shows that the many pollution sources here, including transport and other things. Every 5 years, under the auspices of the United Nations, under that commission, UNSCICP Vegetation, mosses are collected all over the Europe, and nowadays we switch to Asia and some Asian countries, and every 5 years, such atlases or reports are published. We started in 1995. Our first contribution was for Romania, for Carpathian. And nowadays, the last issue on the front view, it's our report from the Joint Institute for the Moss Survey 2015-2016, where more than around 40 countries participated. So how the program, the ideology of that program developed? First, heavy metals. Starting from 70s, heavy metals were most, say, fashionable object of investigation. Then it was decided why not to determine nitrogen, which is very important for agriculture. Then in 2000, starting from 2010, persistent organic pollutants become more and more important contaminants to be assessed. Radionuclides were well known to be determined by Moss-Baer monitoring technique, but starting from 2015, several countries participating in the program, they contributed results on measuring radionuclides in moss samples collected in the territories of their countries. And my favorite topic nowadays is cosmic dust. Cosmic dust is a well-known phenomenon which comes on Earth from space. And to assess its role in agriculture, in different, say, health effects, it's a very important topic, and we hope it will be also accepted by the program. Now I switch to Joint Institute for Nuclear Research, with how many countries we collaborate. Those in blue are the member states of the Joint Institute, and in red are non-member states, but we collaborate with them. For free, we analyze their samples and even help to grow their young generation, to teach them how to collect moss, how to analyze them, how to interpret data. This is a result where all results are coming to Joint Institute. In our institute, there is a laboratory on information technology where top-level programmers are working. Alexander Uzhinsky is one of them. He created excellent data management system on the cloud platform of the Joint Institute. So 40 countries may press the button and they upload their results, and we can analyze them at one attempt. So we can construct maps like those examples you see here, because every sampling site is characterized by coordinates and concentration of the element pollutant. So we can create maps like you can see here. That is development of the modeling of the process. So laboratory of information technologies provide us with possibility to interpret data, and besides that to model, to predict data which are based on spate images and MOS monitoring data. That is just for your information how many MOS samples. Every dot corresponds to one sampling site. So more than 5,000 samples were collected in MOS survey 2015-2016. On a more large scale it looks like that. You can see Scandinavia, quite dense sampling map, and some areas over the Eastern Europe, not many. But what's important, for example, between Black Sea and Caspian Sea, you see dots, it's Georgia and Armenia, and Azerbaijan a little bit number. So the information from analytical data could be converted with GIS technology to such map. At one glance, you can see the distribution of concentration of arsenic. Arsenic is a toxic element. It belongs to the group, to the first group of toxic elements. And you see contamination in the red colors. It's more than, say, median value, and red spots also you observe between Black Sea, Caucasus, because there arsenic industrial activity was very well known in the times of the Soviet Union. Now it's not active, but still the traces of arsenic exist. That is the picture for cadmium. I briefly show you some pictures just to get impression how important and how useful this information could be for the decision makers. At one glance, we can see there the elevated concentration of elements represented in the deposition of dry and wet deposition. Iron, for example, is here. That picture shows the arrows correspond to the Russian Federation. You see Russian Federation for aluminum, for antimony, also toxic element arsenic, cadmium. It's more or less elevated level of concentration here. All in all, in our program in 2020, 21, 22, that is the latest MOS survey. We just collected MOS's data, are not yet processed. But all in all, even in the years of COVID period, 3,437 samples all in all were collected, which will be analyzed and prepared in the form of GIS technology maps, and information will be delivered to the United Nations and then spread to European Union, to other interested countries. These are just small examples showing how young people collect samples. I do hope that some of you might be interested. Please contact me directly, and we should invite you to the program to work with us, and you will do something useful for your area. That is Moscow region. You can imagine it's an industrial territory, a lot of industrial satellite towns here, and we collected samples all over the Moscow region. That is my PhD student who is collecting mosses, and moss carpet is very well developed in Moscow region. Another example shows very accurate attitude in Italy. They have selected area, and you see they made a square 20 by 20 kilometers, and practically in the middle of which spot you can sampling site. Because one sample is air. One sample is collected from the area by 20 by 20, 17 by 17 kilometers, square kilometers. So it's air, it should be large scale. This is just short example, Chechnya, Stavropol territory and Chechnya. They collected samples of the area in the mountains. It's quite hard to collect samples there. Now from air pollution, you, I guess, realize the importance of this research. I switched to another aquatic ecosystem. We collaborate with atomic energy agencies naturally. They keep an eye what is going on the reactors. And so we participate in so-called coordinated research projects and regional atomic energy agency technical cooperation project, which provide us with grants, which allow us to purchase equipment, to participate in different events, and to train youngsters in the best laboratories of the world. So the topic of this research, study of temporal trends pollution in selected coastal areas by the application of isotopic and nuclear tools. Our project on that background sounds as the last line, study of temporal trends of pollution in the Russian coastal area of the Black Sea by nuclear and related analytical techniques. Here you see sampling areas which belongs to the biological station of the Moscow State University. Certainly we don't collect samples ourselves. We collaborate with people who have access and proper equipment to collect samples for us, like bottom sediments, just soil, some aquatic plants like those who are mentioned here. For example, we examined area. It's a great resort of Russian Federation, Anapa recreational coastal zone, but there are a certain number of pollutant sources there. So we need to control what is the aquatic situation in the Anapa Bay, for example. Results were obtained, published. They showed that contamination exists, but it doesn't exceed, say, critical norms, so more or less objective. That picture shows the Egypt territory. This is the Nile along which life exists. And all in all, if to believe that global warming will spread, so Mediterranean Sea, which were not, will just flood the northern part of the African continent. Alexandria, you see delta of the Nile delta, and part of the delta will be under the waters. And it's very important and very timely to examine what is the environmental situation which later will be subjected by water, then dissolve of certain elements, toxic maybe, non-toxic, will just change the environmental situation in that area. We collaborate with many institutions of Egypt, like 5 of them, and we collected samples from the Upper Nile, from Sudan to the deltas. You see so many samples in the Delta Nile. And then the central part was also collected. So the basin of the whole Nile was under investigation in the Joint Institute for Nuclear Research in our collaborative study with Egyptian scientists. That is one of the, I would say, great publications, Geochemistry of Sediments and Surface Soil from the Nile Delta and Lower Nile Valley studied by epithermal neutron activation analysis. You see, 800 citations is a tremendous number that gives you an impression that our research is well accepted by scientific community and they are requested. That is most important. We also carried research in the Alexandria Delta and assessment of Mediterranean coastal waters affected by eutrophication, anthropogenic contamination of the Suez and Ismailia canals and the Red Sea. So our research with Egypt is developing very well, and Egypt has become permanent member state of the Joint Institute last year. So it's naturally that we are very enthusiastically looking for development of our research with these countries. This is South African project, study of levels of priority aquatic pollutants in South African cultivated bivalve mollusks, so-called the South African Mussel Watch. Mussel Watch was a project established by United States in the first part of the last century. We extended, it was a kind of resurrection of this project. We spread it to South African continent. All in all, we collected mussels in these yellow dots you see here, Saldanha Bay, quite close area, and Danger Bay, open waters. And we obtained results which showed contamination in the closed area and quite normal in the Danger Bay. What is important, as you know, Cape Town is the port just between Atlantic and Indian Oceans, and collecting samples like different kind of mussels, like you see here, black bivalve mollusks, we can assess environmental situation from, say, Mozambique, South Africa, Namibia, and even Angola, collecting these bivalve mollusks, analyzing them, because they filtrate the water, and due to that we could assess the contaminants existing in that area. So these results were highly appreciated by the South African scientific community. We received big grant for carrying out this research on a full scale. I collaborate with people. The right picture shows a guy with the mussel in hand, Jacques Bizoudenot. It's our collaborator from South Africa, professor of the Stellenbosch University. He is the owner of the farm. That is his own farm where we get mussels just from his hands, and we analyze them and receive results which allows us to receive big grant from South Africa. And our recent publication, Trace Elements Risk Assessment of Consumption of Wild Mussels Along South Africa Coastline. That paper was published in the Journal of Food Composition and Analysis. It's quite a respectable journal. And I must say that assess of risk assessment is a very important feature, that we not only analyze, we not only get results, what we try to interpret data from the point of view of the interest of community. Risk assessment, that means if you eat a lot of mussels, is it useful for your health or not? In that respect, I think that paper is just reflect our intention to show our results from the point of view of the usefulness of them for the community. What else I would like to show you in the end of my presentation, because I guess the audience consists of young people who are interested in their professional growth. Joint Institute is a good base for training young scientists, to teach them for not only environmental research, to teach them methodology, to teach them how to collect samples, how to prepare them for analysis, and most important and exciting, data interpretation, of course. It's great joy to see the results in the form of some meaningful effects. Here you see two guys who defended their PhD based on the results obtained in the monitoring research in Joint Institute. This girl, you see, I look at her with admiration. Her name was very long, Nkatomba Zikhona Ndlo. I called her our Zina, and now even in South Africa they call her Zina. And that is the cover page of her PhD thesis, Elemental Analysis of Mosses and Lichens from the Western Cape, South Africa, using instrumental neutron activation analysis in Dubna and ICP-MS mass spectrometry in South Africa. So we work from both sides. Part of the work is done in the Joint Institute, part of the job in their countries, and joining these results we obtain wonderful outcome which really serves the benefit of the humanity. That picture shows a girl from Albania. Albania is not a member state of the Joint Institute, but it happens so that we managed to arrange half a year staying of this girl in our institute, and final output of her staying and hard work, air pollution in Albania. Again, PhD thesis, and that photo was taken in Budva, Montenegro, at one of the Joint Institute research school on nuclear methods in environmental science and medicine in 2018. And the very last picture of also my PhD student from Belarus. That girl collected samples all over the Republic of Belarus, and Belarus was affected by Chernobyl, if you remember. And the topic is brio indication. Brio means moss. Moss is used for atmospheric fallout of pollutants on the territory of the Republic of Belarus. And so it was defended in Kaliningrad, and the date of her defense you see here, February 2015, 2022. And that picture, very dear to my heart. It's not my picture. It is taken from some report of youngsters who give their talks on the final meeting after their training in the Joint Institute. You see the title, Dream Team. I like that picture because it reflects the interaction of youngsters and scientists of the Joint Institute. Dream Team, you understand what does it mean? That means that we work and we collaborate, we become friends, they are like my children. And all in all, I would say you are very welcome to visit our schools and to learn more about Joint Institute for Nuclear Research. Here you see the wonderful pictures from different seasons. We have River Volga with ships, we have winter for swimming, for skiing, for different training, for different physical exercises. So Dubna is a wonderful place for life, to live and to work. Thank you for attention.